Hello guys, when you take a look at job ads for senior developers, Laravel and PHP, you see solid principles mentioned quite a lot. So this is an example, understand solid principles. Another example of a job ad, understanding of refactoring and solid principles. And another one, a lot of requirements, and solid is among them. So solid is pretty much a requirement for senior developers, but I see a problem that for Laravel specifically, I don't see many practical examples of how solid should be applied, so I decided to shoot this video, which actually turned into a full course. So like a month ago, I started this research on how to sum up the solid in one YouTube video, and I realized that I cannot do it in one video, so I turned it into a course, which is now officially released. So this video will be a summary of what is essential you need to know about solid principles with examples, as I wanted, but a short version. And if you want to dive deeper with even more examples, there is a course on my Teachable platform, Solid Code in Laravel. The link will be in the description below, and also I will talk about this course at the end of this video. For now, let's go to the basics and let's see what solid actually is and how you can apply it. First, a bit of a disclaimer. When doing the research on solid, which started from Wikipedia page on the concept itself, so there are 5 principles of solid, it's quite opinionated. So these are core concepts, but they are transformed by various people in different languages, in different frameworks, in quite a different ways. There are people who swear by solid, there are people who hate solid, there are people in between. You may find a lot of different articles on solid on the web. So please filter all the information, including my own, through your lens, your situation, and apply to your projects. Now let's get practical. The first principle of solid is letter S, which is single responsibility principle. And this is probably the one that you will use the most because it's the most practical. So it says that every entity, every class, or every method should do only one job or have only one reason to change. And probably the best example of that in Laravel is bloated controllers. And I've been talking about that on this channel multiple times. I have a lot of videos on how to refactor controllers into some services or something. So let's take a look at another example. For example, if you have store method, which takes care of a lot of things. So it takes responsibility for validation, then some custom logic of calculating something, for example, getting the invoice number, then actually creating the record, which is fine, but then creating additional data based on some logic with another loop, with another attachment of many-to-many relationships, and only then redirect. It's too much. And I've seen even worse example in my career, so this example is totally not the worst. So instead of doing all of that in the controller should be responsible for, well, controlling the situation, getting the parameters, calling whatever methods you want from external classes, and then returning the result or redirect. So instead of this store method, I have another one, a better one. This store method is doing the same thing, but it's much shorter. So the validation is in the form request class with the same rules. Then creation of all the record is in a service called invoice service, which also is doing the same thing, but in a separate class, separation of concerns. You just put in the parameters. Those parameters may be in one array, but I've chosen to make them separate. So it would be totally clear because that store new invoice may be potentially called not from controller only, maybe from unit test or from artisan command in the future. So you just call the service, get the result of invoice, which you will use also in the redirect back of which invoice number it is. So this is a better controller under single responsibility principle. And even if we go one step further, inside of that service, we can separate the concern of getting the next invoice number. So even within the same method or within the same class, you can create a separate method or separate class maybe for invoicing of get next invoice number, because this method of store invoice is not responsible for getting the invoice number. It's kind of against single responsibility principle, and having a separate method for that is often better. The second principle, letter O, is open-closed principle, and it says that the classes or entities should be closed for modification but open for extension. What does it actually mean? The best example in Laravel is packages. So whatever is in vendor stays in vendor and you cannot modify that. So it's closed for modification. but it's open for extension. And I will show you an example based on our own package of Laravel invoices. And all you need to do to generate that invoice, you specify the buyer, the seller, the invoice items, and just call the stream, and the result is this invoice, the PDF file on the screen. But what if we want to change some description, for example, and add more parameters that packages don't support? You cannot edit the package, you cannot edit anything in vendor, but you can extend the classes of the package. So for example, in our package we have a class called invoice item. And in invoice item there's a title, for example, but there's no description. What, for example, if you want to add to that invoice, instead of just service 1, and then some description underneath that service 1. So you would want to have something like invoice item, title, and some description, for example, like this. You cannot do that directly because the method doesn't exist, but you can create your own class, and I've done exactly that. I just created a class in app classes. The folder could be whatever, app services, app utilities, whatever, that's your choice. It's just important to have the namespace right, and then you extend that invoice item class from the package, and then you can do whatever. In my case, I define the description, I set the description, and then in my main controller, instead of doing invoice item, I choose invoice item extended, like this, and I add that to the app classes. Not sure why my PHP Storm underlines that, but it underlies the controller as well, so some weird settings are gone. But anyway, I create an invoice item from my own class, which extends the vendor class, the package class, and then I can use description like this. And then I can use that description in the blade file where I show that item, and I have that already prepared, so item description is available then. And then if I refresh that invoice, the description is here. So this is an example that you create packages which are closed for modification but open for extension. And if you create classes not only in packages, if you create classes which should not be modified, like interfaces, for example, or some base classes, this would be an example of closed for modification but open for extension. The third principle, letter L, is Liskov substitution principle. Liskov is for surname of Barbara Liskov, who created that principle, and it says that the classes should be interchangeable. So if you have two classes doing the same thing and implementing the same interface, for example, you need to be able to safely change one class with another without breaking your application, which basically means all the parameters, return types, and expected exceptions should be identical. And let me show you an example. So imagine you have employee salary calculator, and here I switched to Sublime Text from PHP Storm because Storm started to underline some weird stuff and I'm not in the mood to fix that at the moment. So let's see how we go with Sublime. Not sure actually, is it better or worse? Shoot in the comments below. Maybe Sublime is better actually to show the code in the future. So we have employee all, like in any controller. Then in the employee model, you have a calculator of salary with get salary attribute. And that calculator is actually depending on the class. There is employee type in the database, which then forms the class name of salary calculator. And then there's a method in designer salary calculator, for example, calculate, and for example, hypothetical example of salary depending on just start date of that employee, and for example, some formula of yearly salary of a designer. Then another class to calculate that formula for developer, so developer salary calculator, and those two classes implement the same salary calculator interface, which says that every class of that interface should have one method calculate, the parameter is start date, and the return should be float. But what if some conditions changed and we want to add some parameter to one of the classes? So for example, for director salary calculator, you need some more parameters, like bonus, for example. This kind of violates the Liskov substitution principle because this class cannot be easily substituted with another class because it has different parameters then. So what to do in that case? You have a few choices here. First choice is to add a default value, which means that even if that parameter doesn't exist for other classes, it will fall back to default value and will not break the application. That's probably the most popular way. But if you have some parameter which probably will be needed in the future for other classes, you may go to changing the interface. If that interface belongs to you, so it's not in vendor somewhere, you can add that bonus to the interface here as a parameter. But then you need to change all the other classes that implement that interface. So in designer calculator, in developer calculator, and all the others, even if you don't use that bonus at this time for those classes. So that is kind of a big refactoring, and it even goes a bit against of O letter of the solid principles. So interface should be closed for modification. So you need to modify the interface in really edge rare cases in ideal world. But we all live in non-ideal world, and requirements do change from business point of view. So sometimes you need to refactor the class itself and then the interface and then other classes. But the best way to describe Liskov principle, Liskov substitution principle for Laravel is basically use type hints everywhere. So you would have the same parameters and you wouldn't be surprised by something like passing string instead of float or the other way around. And also the return types of methods are really important. So if the return type or parameter type is wrong, so PHP would immediately flag the error and would not allow you to go to the buggy situation. So the most practical thing you can learn from it: use type hints and return types everywhere, and use default values for the parameters that may be not passed. Letter I in the solid principle stands for interface segregation principle, or in a more human language, interface separation principle, and it's used a lot in Laravel itself in the framework, but I will show you an example from my own demo project in Laravel. For example, you have various classes for various reports of invoices or whatever. The example is not really finished, it's more like structurally finished. So you have report by month, and you have report by product, report by something else. And they all implement report interface. Report interface has the rule of two methods: get the data and download the report, right? But what if in the future there will be some report that doesn't get downloaded, it only gets the data visually? Then you would be forced to implement that download method even if you don't use it. So one of the other definitions of that I letter in the principle, that class should not implement the methods that it doesn't need. So the typical violation of this I letter principle, interface segregation, is interface with too many methods. So like 10 methods, but actually the classes that implements that interface need only like 5, and the other 5 would just throw an exception. So I've seen people literally doing public function name and then just throw new exception. This method doesn't exist for this case. So what if we have something like report by product that only gets the data? Again, not implemented, just a structural example, but it doesn't get the download method. For that, you would separate the interfaces. So instead of having one report interface, you would have separately report data interface with only the get data method, and then report download interface with only the download method. And then report by month would implement both of the interfaces like this. So instead of implementing report interface, you implement comma-separated report data interface, report download interface, and maybe something else. And then the other report would implement only the report data interface, but not download. In Laravel core, you may see quite a lot of small interfaces with one methods like JSONable, HTMLable, and stuff like that. And Laravel classes or packages classes may implement all of them, comma-separated, or just one or two of them. So this is the separation of interfaces, and each interface is responsible for their own small set of features. And letter D finally is the dependency inversion principle, which says that interface should not depend on the concrete implementation, or class should not depend on the concrete implementation. Instead, classes should depend on abstractions. It actually is hard to understand, right? But let's take a look at practical example. For example, you have a controller. Same scenario, report by month, and the parameter of that is interface of the report, which may be resolved by different classes. For example, you have a default report by month class, which implements that report interface, but you may also have some testing report by month class, which would implement get data and download in some kind of a different way. Maybe get data from a different database or from different source, maybe download with some fake downloader and not actually download. So you have something like this. test report by month, it's not implemented because it's kind of a structural theoretical example, but that class also implements report interface. And then in your controller, in some situation, you want to use the main report. In other situations, test report, for example, on local environment or staging or production. And then in the controller, you pass not the class like report by month, something like this, but instead you pass the interface. And then that interface should be resolved somewhere else. For example, often case it's an app service provider or another service providers. You choose. If the environment is local or staging, you resolve that report interface with test report by month class with this one. Otherwise, with the main report by month. It allows you to not change the main controller if you have some other third class in the future. For example, you have, I don't know, SQL Server report by month. If you want to have a different database, then you just create that class, which implements the same interface. So you don't change the controller at all. You just add your own class and add that here to the logic of how it would be resolved, in what situation that class should be used. So, after this short or not so short practical overview, do you understand those principles better? My guess is that for a lot of you, all of those interface stuff is quite theoretical and not really applicable in everyday smaller Laravel typical projects, and you may be right. And I would argue personally that you need to know mostly two principles out of those solid in practical everyday life. So, single responsibility principle, it's mostly about bloated controllers, too big controllers, but not only that, if you have too big classes with too many methods, or if you have one method with like 100 lines of code, it may be separated into different methods and stuff like that. This is a really widely used principle of single responsibility. And also Liskov substitution principle, which in Laravel or in PHP actually comes down to use type hints everywhere and return types everywhere and try to follow your own rules, establish the rules of avoiding the surprises in the code, what it should be returning in which case. All of the other principles are mostly about interfaces, which you would be using only if you have certain projects, certain project types, like bigger projects which would actually have separate implementations of something, or if you would create packages, or if you would create your own frameworks like Laravel. So if you need your code to be reusable by someone else and you don't know that someone else, how would people as clients, as customers would use your code? Then your code needs to be following all those solid principles with interfaces and strict rules in order not for someone to break that code in their implementation of your interfaces. In general, solid is not a one-time thing that you can apply. It's more about way of thinking when coding. So when coding, you need to constantly ask yourself two questions. First question, who and how will use that code in the future? So imagine yourself in 6 to 12 months, imagine your colleague, imagine you hire a new developer, it may be a junior developer. Think about who would consume that code in the future, and it may be yourself. So in your mind, talk to that future self and ask if that code will be still readable, maintainable, and easy to fix the bugs if they appear in that part of the code. So that's question one, who and how will use that code? And question number two, what may change in the future? It may be changed from another developer or yourself, or it may be a business change. So for example, if you're implementing PayPal payments, what if in the future you add Stripe, Paddle, or something like that? Is it worth to create an interface or not? Maybe even talk to the stakeholders, to the clients. What do they expect to happen in the future? And then that may affect your current coding structure. So second question, what may change in the future? And finally, if we go back to those original job ads that I've shown you in the beginning of this video, those job ads talk about solid principles not because you need to apply all those 5 letters in the code. What they mostly expect from you is for your code to be solid, to stand the test of time, because it's probably the team working on that project. The project has a long-term vision, so your code should not break like Jenga tower if something is changed in the future, because business requirements change quite often, especially in fast-growing startups, and we have a lot of startups on the market these days. They constantly pivot in their direction, so your code should be stable but at the same time flexible enough, and that is partially described in those solid principles. If you want to get even more practical, as mentioned in the beginning, I had to expand this video into a full course, which is published now on my Teachable platform. So here you can see it's solid code in Laravel, and there are two ways to get this course. First, purchase it individually for $29 plus VAT if that's applicable to you, or you can purchase yearly membership for all of my 20 courses at the moment. And in September, I will launch one more with Flutter and API. So if you want to get all of those, it's a better deal, in my opinion, to get the yearly membership for $99 per year plus VAT again. Now let's briefly take a look what's inside of that course. So in addition to explaining all of those letter principles with more examples, a few for each letter, then we'll take a look at open source repositories where they apply those solid principles. Also, how to make your code solid. So this was the video I was preparing for quite a lot of time. What are the tools that may help you to test if your code is solid or not, or what to refactor? I've chosen 3 tools with 3 open source projects, and I will show you the results in this longer 22 minutes video. And then I will touch on some other related principles to solid and also criticism of the solid, why solid may be considered as an older approach to the architecture, and what are the alternatives. So if you want to get deeper, the course is on laraveldaily.teachable.com. Here it is as my all other courses, and by support those courses, you actually support this YouTube channel as well, because the more courses I sell there, the more free time I have to shoot free videos here on YouTube. And if you want to discuss anything about solid, or you want to challenge my opinion on something, because again, a lot of this stuff is opinionated, let's discuss in the comments, and see you guys in other videos.